Hello everyone, I'm sure you are doing awesome. So in this video, we are going to explore a more subtle yet a very critical concept of the database system that is being called as isolation. So in the previous video, we went into the detail of the atomicity and which is the first property of the acid. And now we are jumping onto the third one. The second one is the consistency among in the acid property that we will cover in our next video, because isolation is way more important, and if we understand isolation in a deep dive mode, we'll be able to understand the durability and the consistency in a more generic way. So isolation defines a very simple thing. This defines that when and how the changes made by one transaction will be visible to the other one. That's all. Like a plain and simple definition. Suppose there are two transactions that are going on. If they are affecting the same set of rows, how and when exactly the changes made by one transaction will be visible to the other. That is the whole point of isolation. That is isolating the two or more transaction over here is the problem statement that we are going to tackle. So before going into the detail, let's take a scenario of a fintech giant, suppose a Stripe or a Razorpay. Okay, so we will try to build something like a settlement engine. And what exactly is a settlement engine, I will explain you on the go. So what happens in a settlement engine is like around 9 a.m. in the day. Okay, there are 10K merchants out there. They are checking their balance. Okay, and at the same time your reconciliation service is updating those same account with the overnight settlements. So for example, like at 9 a.m. this merchants are checking something, or let's be more precise, like uh, 0 minute and 00 seconds, and by the time it starts coming in the data for you, the reconciliation also starts somewhere around 0.001 milliseconds. Okay, so now is there a possibility that the merchant might see a inconsistent balance during this process? So this is overnight settlement is happening there, and when this thing is going on, this query will run, the first query will run, and also there are some update will run. So this is probably, we can say, kind of a select query that is going on, and here something like update is going on. So the problem can happen that we might see a inconsistent balance during this process. Why and how, we will try to explain through a further more deep dive into this example. Okay, so inconsistent display of balance might happen here. Okay, so let's take a deep dive into the settlement engine process. We will understand why it might happen. Okay, so let's understand through this diagram. So here there are around 10,000 merchants. They have started a transaction. So this whole thing is a basically a single transaction. Okay, all these things that are going on over here is a single transaction, and what they have done is they have started some kind of a calculation at their end by taking care of or by taking the result of this transaction at t1 or the timestamp 1 level. Okay, so what they have got is like by selecting their balance, they got their account has around 1,000 rupees of balance. Right now on that very moment, so for example, just right after this, like 1 millisecond maybe, when they got this transaction, they got another update which is being run by the reconciliation process. So reconciliation process can be something like, suppose there are some of the transaction that didn't succeed on a previous day due to banking time. Okay, some of the NEFT, or it can be some RTGS which didn't succeed. So it just succeed because 9 a.m. is probably the bank start time. So those money started getting poured into the database now. So for the same transaction, then again suppose they want to do some kind of a calculation around it. So now what would happen is, in between this reconciliation money started uh, getting poured into the database, and they are being committed as well. Okay, so this transaction is completed here. So but this, for this longer transaction where this 10K merchants are creating their reports, they see that after 1 second of time their transaction is returning 1500. So the problem that is happening is, under the same transaction, okay, under the same transaction, the first read uh, returns a value of $1000, and the second read uh, returns a value of the uh, value with $1500 with the same SQL query, same select query. So this is definitely one of the inconsistency problem, and how we can solve it, we will gradually come into that. But before that, let's take another example, suppose of a trading bot. Like trading bot, if you see, okay, so trading bot, if you see, what they generally do is, it generally checks a certain value. Okay, whether like this many number of shares are there or not, based on that it keep on buy or sell. So suppose your trading bot runs in a condition that in case your account has more than 200 share of suppose Reliance, then it will sell 100 shares. Like you do not want to put more than 100 more than a stipulated number of shares of Reliance, so you are going to sell the moment it crosses 200. So for example, like you are getting gifted by someone a suppose your current shares of Reliance is something around 170. Okay, and somebody gifts you around 50 shares. Okay, so you get gifted 50 shares. But the thing is that those transaction is has to be done via your brokerage account or some other account where you might not be having the enough balance. So what what is the problem that we might run into? Let's understand through a diagram. So you see this brokerage app decided to gift you something probably of 50 shares, and your current share number is 170. So in this particular moment of time, your share for a whisker of second becomes 220. But interestingly, the transaction isn't being committed because through in your brokerage app, suppose the account that is being linked, it doesn't really have the enough balance. So what might happen is, our trading bot at that very moment, okay, so at that very moment our trading bot see that there are 220 number of shares. So what it will do is, it started selling the shares, and what it does is, after seeing that there are 220 number of shares, it sell 100 shares. Okay, as we say, like if because it is going beyond 200, so we are going to sell 100 shares. So now that we sold 100 shares, now what has happened is, this transaction, due to the insufficient balance, okay, this one, due to balance issues, this transaction get failed. Okay, so now that it got failed, so it get rolled back. So now what happens is, because you have already sold 100 shares, now it ended up with only 70 shares. So at this point of time, Once the rollback happens, once the rollback happens into the database from the brokerage app, your leftover is 70. And there can be way more worse cases than this. For example, suppose they have decided to gift you like 250 shares, and at initial level you have only 10 shares. Okay, so now if it sells like 100 shares, then your balance will be minus 90, because at this moment of time probably it will see that okay, 260 shares are there, so it will sell 100 shares, and the number ideally should become 160. But the rollback happens, right? With this rollback, this 250 number of shares are not being added. So what happens is this 100 shares are being deducted from 10, and your system goes into a completely inconsistent state. And this particular error, if you just see carefully why it is happening, the reason is we are, or like we have read an uncommitted transaction. This particular transaction from the brokerage app was not being committed, and we read that uncommitted transaction, and that is why there is a like a very basic isolation level that we have, that is being known as a read uncommitted. That is a very risky one. Like as a database developer or even as an application developer, we should never allow our transactions to read anything which is uncommitted. So that is the first principle of isolation. Never read any uncommitted transaction. And when can we read uncommitted transaction? If the database isolation level is set to the read uncommitted. So this is the first time I'm introducing the concept of isolation. If two transactions are going on and if my database isolation level is being set to the read uncommitted, then one transaction could read the other transaction's uncommitted data, and that invariably in all the system would introduce problem. So in under no circumstances we should be allowing two transactions to read each other's uncommitted data, right? So now that we understand what exactly the first principle of isolation, so please remember this thing: read uncommitted is not being used anywhere in the industry. Like whatever my experience had, I have never seen it. Even PostgreSQL by default, it never allows two transactions to read each other's uncommitted data. So for example, if I take PostgreSQL, so by default its isolation level is read committed. So that means only if my uh, transaction have a committed data point or a committed transaction point, save point, so from there only the other transaction can read that particular data. Okay, so I hope this part, this isolation concept that I wanted to introduce to you through this trading bot example or even this 10K merchants example, like where we are trying to create a settlement engine. In both the cases, if we just mark our transaction as read committed, like that only read the balance once something is being committed, we will be able to mitigate most of the issues. Here there are some other implications are there which definitely we will cover for the settlement engine, but uh, the thing is that we always have to make sure that if we are reading some data, we shouldn't be reading any uncommitted data. So this has a different timeline problem, which we will come in some time. But I hope this part is clear. The differences between the read uncommitted isolation level and read committed isolation level. So now that we understood the problem that read committed solved, but let's take a more further broader view. So the thing that I want to point over here is, like, for this one, read committed, in this case, as you can see, read committed can also fail some use cases of the DB integrity. And what are those use cases? For example, let's take this report generation sort of a thing. Like, we are going to generate a year-to-date invoice for our SaaS customer. So suppose I am running a SaaS company. You could think of some very well-scaled applications as well. For example, AWS or Azure. There you can go, and there you can always see what exactly is the my year to date or my month start to date consumptions, and how many in which price tier, how much I have, how much cost I have incurred, right? So generally you are going to see a sum over there. So for example, here if you see how these things happens is, suppose you are generating a report from 1st Jan to date time now. Okay, now at the top of your report, you will always see that you are generating a sum. The sum is of like $100, and then there are line items. Like, line items could be your virtual machine instance took this much amount of like $10, your networking stack took $10, your Azure functions or the serverless components took $10. In this way, there are total 10 items are being listed there, suppose. Okay, so now during this report generation process, uh, what happens is, you are reading all your API calls and this kind of usages. Now, in the meantime, suppose AWS or in Azure have some kind of a imagery support as well, which you wanted for your application. So for that imagery, what happens is, like, you add it as an add-on. So earlier it was $100, now you make it a $50 more, right? So now your API support this imagery support, that is some kind of a base64 encoding, all the API that AWS or Azure have, you can take those advantages. So now again, let's take the timeline of this transaction. What happens is, it is currently in a read committed. Okay, and what is going on here is, like, there are two basic transaction will be done. The first one will be the report generation, where I am going to generate my report with the line items. Okay, in the meantime, what happens is, like, there is another transaction of your add-on happened. So suppose at your t1, or like suppose t1 equal to 0 second, this guy started this transaction. Okay, and suddenly when you are done with the reading and you have printed your actual usage or got through your select query, what you have done is, you have like, as a user, you have added another plan. So suppose this thing is happening at t2 equal to 1 second sort of a time. Okay, and generally it is under milliseconds because all these transactions. So in the meantime, when your final report or the line items are getting generated, suppose during the 2 seconds of time, what you will see, that the line item is getting generated, and with the add-on of this $50, like initially when you read, in your initial read, the usage sum was 100 and your add-on was $0. So now with $50 plus, your item total is becoming 150. Okay, but what was your actual sum you have given? Actual sum you have given as $100. So here the problem, you see, I have read the committed transaction, like this transaction has been committed, I have read the transaction, but still what has happened over here is, I am getting this line item, that the total line item is generated 150 because I have read this committed, but the actual sum I printed on top of my report is $100. So with this kind of report or this kind of design, like, not only it is a trouble for the end user, we can be liable to some like the legal or some other damages as well, because this causes a lot of confusion, and these are the monetary reports. So in this case, what happens is there is a different isolation level that is being taken care, that is known as a repeatable read. So what is a repeatable read? By definition, using if we mark any transaction as repeatable read, it makes sure you to reread a row, okay, not any other thing other than the row. Suppose the row that I have read, where my add-on was showing as $0, okay. So now if I again read that add-on row in the same transaction, I am going to see $0 only. Although, like at this point of time also, I am going to see $0 only. Although the actual value is $50, and that is being known as a repeatable read, as it is like quite self-explanatory. Like if there is a row, okay, the transaction can reread a row and always gets the same data. So this kind of problem that we that we can avoid over here is if we have some kind of a dirty reads. Like I'm not very much like into the this computer science terms, but still for academic interest, let's use this. Dirty read means you have within your transaction you have read a data, and in the meantime that data gets changed into something else, okay. So that means that data becomes dirty for you, and that is dirty read, okay. Now in this case, what happens is this kind of, like if we mark something as a repeatable read, this dirty read can be avoided, okay. But there are cases when even repeatable read might fail. So let's see what are the cases. So the key before understanding the next section, uh, please note that a transaction reread a row, we have only mentioned about a row over here, right? Nothing else. So case when a repeatable read might fail. So here, uh, like our invoice transaction started, and in the meantime, when you have read the usage as $100, a new row is been added. So earlier case, what happens is the add-on row was updating, and here what is happening, a new row is being added for the API usage. So what would happen over here is, if you see, for this case we will still get 150, because uh, over here this transaction will not be like, even if you are marking it as a repeatable read, it will see that okay, my earlier row is anyway giving me 0, but my new rows are giving me that whatever the 50 or the $60 extra, right? So to stop that, what we can do is we can use something like serializable, okay. And the things that I have written over here is that is very important to understand. A serializable, it not only locks the existing row, okay, from which I have read the data, it also logs the possible matches where of my where clause. So for example, in this case, in our example, we have uh, read the usage and got the sum as $100, right? Now this is a very strict isolation level that we are going to apply, that is serializable. What it would do is, for all for this where query, like this is going to be like something, some sort of a select, um, sum of some cost sort of a thing, and from some table name, and there will be a where user id. So for this particular user id, whatever the data that has been involved in this sum, okay, all of them will be kind of locked here for the update. And that is being, there is a very important term to it called predictive locking. It locks, so it makes sure no any other transaction can access that particular um, that particular rows, or alter those particular rows. Rather, they can read, but they will not be able to alter any of those rows. And what it does is it completely halt this transaction. This is an advantage as well as a disadvantage as well. We will come into the disadvantage part, but understand this thing. Now what we have is we have a complete serial order. How? So this become my transaction 1, and once it is completed, once this guy is completed, then only this 2, this transaction will happen, right? So this become a complete serializable or in a ordered manner. That is why it is called serializable. Like in a serial, our transaction is getting executed over here. Okay. And what exactly is the disadvantage of it? The disadvantage is because it is a serial, it reduces the concurrency, right? If the same rows are involved, then only it will halt, otherwise it won't. Just put this thing into a mind. But anyway, because it is halting the transaction and only one after another it is being executed, so in some way or other it is causing uh, it is causing a problem to the concurrency, and of course like your applications overall speed will be hampered in some way over here. So now let's try to summarize the things that we learned. So under the read uncommitted, okay, read uncommitted is no longer, I mean, used in any system. Like I haven't seen any of the system in my lifetime, whatever I have seen, which are using read uncommitted. They are mostly using read committed. Okay, and this is a default, and it solves that dirty read problem. Now alongside read committed, a single transaction still can have the problems which we highlighted over here. Okay, that can be solved if there are two different, like same rows are involved, then that can be solved with a repeatable read. But if there is like a additional rows are involved with the same where query, for all anomalies we can apply serializable over here. So any kind of financial state settlements, like I was talking like reading about the Razorpay, how they handle this kind of transaction, they are using serializable very strict manner. So even if there is a few seconds delay, they can handle it, but any kind of financial anomaly they cannot afford, right? So now after seeing all these things, you might be thinking that in my use case, sometimes I need to apply read committed, sometimes I need to apply serializable, sometimes I might need repeatable read as well. And the question might come, can we apply different isolation level for the different transaction in my DB? And the answer is a big yes. Yes, we can apply different isolation level for the different transaction in my DB. So for example, if I see that this is kind of a transaction that is being going on, so uh, at the top, this is a Postgres SQL syntax. At the top, I can set it as a transaction isolation level to serializable. And for any of the stored procedure that you are writing or function that you are writing, which you want it to be a particular isolation level, you can set it accordingly. And this is a very important aspect, like setting different isolation level for the different transactions, understanding your requirement, that is very important, and this is kind of a hallmark of a robust DB design. So now what we are going to do is we are going to see these things in action. We are going to see in a real life application how this thing helps and how they actually pan out in a for different sessions.
Okay, so now let's go ahead with our demo. Our demo is quite primitive, I would say. So what we will be doing is we will create two sessions of our same application, and from that two session, we will try to see that if I am trying to block a same seat. So for example, you are probably creating some sort of a app like a Book My Show, where you are just keep on booking the tickets one by one, or IRCTC per se. Okay, in IRCTC, although we cannot pinpoint the seat, so I'm taking example of Book My Show. Suppose there is a certain seat you are booking, as well as another person is booking. So what would happen in that case if we have read committed? How the read committed or the repeatable read or the serializable will going to uh, restrict the flow for the users towards the database correctness. That is something we are going to explore in our demo. So over here, as you see, like what we are trying to do is we are, for every single transaction that we are doing, we are trying to set the transaction isolation level. So we'll have a drop down, and based on that we are going to set our transaction isolation. And once our transaction starts, what we are going to do is we are going to create another session, and there is a certain delay of 15 1000 millisecond, that is like 15 seconds of delay will be there. So in that meantime, I will try to book the same seat using another session, and then we will see that whether both of these sessions are among these two sessions which is getting succeeded and which is getting lost in the uh, mm, time. Okay, so let's take a let's run the application and see it in action. So as you can see over here, like I have ran my application, and don't worry, like I'm going to give this full application code base. I have already put it into the GitHub. So it will be in my description as well as in the comment section where you can clone this and see this. So the idea here is there are two different sessions are there. So for this concert seat booking, you see this is a session with 36F, and there is like a 4FP. Two different sessions are there. And what I have done is I have created a database in there. There is a particular seat A1. I'm going to only demo that a single seat only. I didn't want to complicate the example with multiple seat and the other options. So what I'm going to do over here is I'm going to book this seat with read committed. Okay, so in both of the places I come and I select read committed. And why I'm not demoing read uncommitted, because like I'm using Postgres. So in read committed, what happens is, as you can see, I have written here that in PostgreSQL it behaves same as the read committed. So read uncommitted is such a like a kind of a disaster, I would say. That is why Postgres by default enforces read committed even if you set the isolation level to read uncommitted. And how are we setting the isolation level? Here, if you see from here, there is an isolation comment that we are passing. Using this, we are setting up the isolation level. So now let me try to book it from this. So I have set the read committed and I'm trying to book the seat, and you see like it is going on right now. And at the same time I come back and I select read committed and I try to book the seat. So both of these transactions are going on. If you see, like because I added that delay over there in my application, so both of these transactions are going on. And you see the interesting part, this is the session I had, the 91 ed 918, right? And here I had this session. So because I started this one first, it shows you that this particular seat is being booked by this guy. Okay, so here also you see someone else reserved the seat during our check. So the because we have put it into the read committed, so we are able to get this idea that even my query selected it, but someone else reserved the seat during our check. Let's see what exactly the code was on this. So you see over here, what we were trying to do is, if we are trying to reserve it, but at that time we see that like my query is not successful, although initially I saw it is like a available one. So it is giving an error that someone else reserved the seat during our check. So if the reserved row is 0. So it is a very simple logic, guys, for the read committed, as you can see over here. So again, what I have done is I again have reset both of my database, and as you can see over here, again the seat A1 state A1 became available. Okay, so now what I'm going to do is I'm going to set it up as the serializable for both of these cases, and let's see how it behaves. Okay, so in the serializable, what I do is I'm going to book the seat one here, and you can see it started again with the serializable. For the other transaction also I have started the booking. So let's see what happens here. So you can see like here, although this particular session itself was able to book it, but you see for this session 7D, it tells that it is already booked by this, and the error that it is giving is could not serialize access due to concurrent update. So let's see what happens in the code there. So in our code, if you see this particular line, line number 203, from here this message happens. So the moment it is like we are trying to do this concurrent update, as you can see, like could not serialize access due to concurrent update. It says very, very clearly, right? So the moment we are trying to do a concurrent update, it just throws an exception. It is not even stopping you or doing something else. It is just throwing the exception. And here you can see like what it is saying is could not serialize access due to concurrent update. So definitely you understand a couple of things over here, that if it is said to be serializable, then no other transaction can't even read that data. Okay, because it is being serialized access due to that concurrent update. And also this serialize will make the database operation a little slow because it is completely halting the other transaction. So that's the video, guys. This is the thing that I wanted to cover over here. So we have covered a good ground, like where we understood all the isolation level, which is very, very important in terms of the database. Plus the thing that we have covered over here is like a small example using different sessions, what exactly happens in looking at the application code basis. So your practice or your homework would be like, probably you can create an application of a similar sort, or complicate a game a little more for yourself, like take 2 or 3 seats together, try to book them in a concurrent way, and try to see how exactly in the read committed, or in the for the repeatable read, or for the serializable, how exactly the database is behaving. So that's the video, guys. Thanks a lot. We'll see you in my next video. Till then, stay awesome. Bye.